Section B. Mercury.
Mercury is the closest planet to the Sun. Mercury is small and lifeless, with no atmosphere. Actually, Mercury is similar to our Moon. Both are geologically and meteorologically dead.
When we say geologically dead, we mean no geologic activity, no volcanoes, no earthquakes. And when we say meteorologically dead, we mean no meteorologic activity, no wind, no rain, no nothing.
Mercury's distance between the Sun is 0.39 AU, or a little bit less than half the distance between the Earth and the Sun.
Mercury's orbital period is about 3 months. That's how long it takes to go around the Sun.
Mercury is a small planet. Its mass is about 5% of the Earth's mass. Because of Mercury's small mass, it has very little gravity.
Mercury has no atmosphere because of its low gravity and proximity to the Sun. What little atmosphere Mercury could hold is burned off by the solar wind.
The solar wind is a stream of ions and other particles that shoot out of the Sun. The Sun has so much energy and radiation, it just picks up the ions and scoots them along. The ions do all kinds of stuff along the way. Bounce around, get caught in magnetic fields, basically just cause trouble.
Section C. Venus. Venus is the second planet from the Sun and is sometimes called our sister planet.
Venus and Earth share similar diameters, masses, densities, and escape velocities. That's why they're called sister planets.
Venus is 0.72 AU from the Sun.
Venus's orbital period is 0.62 Earth years, or about 225 days.
Venus has a pleasant milky green color from space.
Venus's cloudy atmosphere is made up of 96% carbon dioxide. The average atmospheric pressure at ground level of Venus is about 90 bars. That's 90 times the pressure of the Earth's atmosphere. The temperature on Venus is also much higher than Earth. Venusian temperatures average about 900 degrees Fahrenheit, or around 400 degrees hotter than your oven at home.
Using radar to probe the thick clouds of Venus and examine the surface, we can begin to understand what happened to make the planet so much different than our own. Exploration has shown that Venus is dotted with volcanoes, many more volcanoes than Earth has.
The story of Venus.
When the Earth and Venus formed, we assumed that they both had active volcanoes which spewed forth water, nitrogen, and carbon dioxide. Venus was much closer to the Sun, however, which made its surface temperature higher than Earth's. The high temperature of Venus kept water molecules from staying together as distinct water molecules.
Instead, water split into hydrogen and oxygen molecules. The light, energetic hydrogen molecules moved around and escaped Venus's gravity, leaving behind lonely oxygens. The oxygens got together with carbon and other elements in the Venusian crust, making even more carbon dioxide than there was before.
So the surface of the planet was roiling with all the volcanic activity, and a whole bunch of carbon dioxide was floating around in the sky, while all kinds of solar radiation pounded down on it all.
The problem is, carbon dioxide traps infrared radiation, or heat energy. So the volcanoes in the Sun were heating up the surface of Venus, and the heat couldn't get out. The planet kept getting hotter and erupting more, and filling the atmosphere with more gas that kept piling up and creating more atmospheric pressure, and everything was really out of hand. Carl Sagan called this the runaway greenhouse effect.
And that's the story of Venus. Now it's a high-pressure, hot oven of a planet.
What else should you know about Venus? Couple things.
Because of the runaway greenhouse effect, the Venusian atmosphere forms into thick clouds made up of carbon dioxide and sulfuric acid.
We told you the planet's orbit around the Sun takes about 225 Earth days. However, Venus rotates once around its own axis once every 243 days. Venus rotates so slowly that a Venus day is longer than a Venus year.
The weird part isn't just that it takes Venus 243 Earth days to make one full rotation. The weird part is that Venus rotates backwards.
Yep, Venus rotates clockwise. The Earth and just about every other planet in the solar system rotates counterclockwise. Remember the right-hand rule? Orient the fingers of your right hand with the rotation of Venus, and where your thumb is pointing is north. That means when you're looking at Venus, north is down. Weird, huh? Another name for backward rotation like Venus has is retrograde rotation.
Best we can figure, Venus's slow rotation and backwards motion happened because something really big ran into Venus a long time ago and caused it to start spinning in the other direction.
Because Venus rotates so slowly, the core of Venus doesn't rotate at a different rate than the rest of the planet. That means that the core of Venus doesn't create a magnetic field.
The third planet from the Sun is the Earth. We learned some stuff about the Earth in Part 1, so there's really nothing new to say. Let's see what the Earth is doing right now.
Crazy planet.
Section D. Mars.
The fourth planet in the solar system is Mars.
Mars was named for the god of war because its color is blood red.
In actuality, the surface of Mars is red because it's covered with blood.
No, it's actually red because there's iron oxide in its soil, the same stuff that makes rust.
The distance between Mars and the Sun is about 1.5 AU. Mars orbits the Sun once every 1.9 years, or once every year and 11 months.
The atmosphere of Mars is very thin, with a pressure of about 1/100th that of the Earth. The low pressure of the atmosphere prevents the formation of liquid water on Mars. The water would just evaporate. The atmosphere of Mars is about 95% carbon dioxide, 3% nitrogen, and 2% other stuff.
The average temperature on the surface of Mars is about -10 degrees. But Mars is tilted on its axis just like the Earth, so it has seasons just like the Earth. That, in addition to the changes between day and night, means the temperature of Mars can vary a lot around that -10 mark.
Incidentally, in 1996, some scientists did a bunch of tests on a meteorite that some other scientists had picked up in Antarctica. The preliminary tests indicated that the rock was formed in the atmosphere of Mars. The next test they did showed the presence of organic molecules. Basically, the stuff in the rock suggests that at one time, a couple of billion years ago, there may have been really primitive life forms on Mars.
What were they doing there? You know, life stuff.
Either way, if life was ever there, we can't see it now.
The surface of Mars is mostly big dunes of orange sand. Like Earth, there are mountains and valleys, but Mars makes them bigger than we do. Mars is like the Texas of the terrestrial planets. It's not much better than anybody else, but it makes everything real big.
In the northern hemisphere of Mars, there are really big canyons. The largest one makes the Grand Canyon look like a crack in the sidewalk. You can see it right here. If we were to attach the Grand Canyon to this one, it would be about this long. The largest mountain on northern Mars is Olympus Mons, which is actually a big volcano. Here's Olympus Mons. Olympus Mons is twice as high as Mount Everest, and its base is wider than the state of Washington. We're pretty sure that Olympus Mons hasn't erupted in a long time.
Mars also has polar caps. The southern cap is mostly carbon dioxide frost. The northern cap is mixed carbon dioxide and water ice.
There is some evidence that there used to be a lot of water on the surface of Mars. If Mars did have water, that would have to have been about 4 billion years ago. Between then and now, Mars cooled down, lost a lot of its atmosphere because of its low gravity, and as far as we can tell, the water froze into the ground.
Mars has 2 moons, Phobos and Deimos. The moons seem to be asteroids that Mars has captured with its gravity. Both of the moons are potato-shaped and about the size of Manhattan.
Look at me! I'm a moon of Mars!